we're doing today is long division. It's been quite a while since y'all have had to do long division. So long division, if you guys remember back to middle school or late elementary, we would draw what some would call the house or the garage, and we would put the first number inside, the second number would go outside. Because we did this to start so you learn how to divide, and then by middle school, high school, it's just plug it into the calculator, let the calculator do it. Now the reason we're coming back to this here is we are going to divide polynomials by long division. But I think it's helpful especially to start off with this here, because the process that we do for dividing these two numbers here with long division is almost the exact same as what we're going to do with polynomials. Because when we divide this here using long division, we're trying to reduce this here to make the first number really simplify out and go down. And the first thing we look at is we have two numbers, so we have 13, two digits. How many times, or what times 13 will get us something close to 29? Or how many times will 13 go into 29? 2 times. And then kind of off to the side, we did 2 times 13, which is 26. And then we put the number under 29, and then we subtract it. Well, 29 minus 26 is 3. And then the next thing we did was we brought the next term down, 36. Then we said, what times 13 gives this number close to 36? So we can do 3. 3 times 13 is 39. So that's too big, yes? So we're going to have to do 2 again. And 2 times 13 is 26. And when we subtract, we get, bring the next number down. Well, this time we know it's not 2, because what times 13 will give us a number close to 108. 3 is 39, so we'll need to have something bigger than that. Because 8 would be 104. 8, 104 minus, so we have 4. Bring down the 2. Well, this one we kind of already have written up. It would be 3. 3 times 13 is. So we'd have 3, multiply, get 39. 3. Then we put either R3, because when y'all first learned it, they told you R for remainder 3. Or we would write it as 3 over what we're dividing by. And y'all kind of remember this process, yes? I mean, for the most part. For long division, it's going to be very similar with what we're doing here with our polynomials. Questions on this so far? Okay. Because there are 2 ways for us to divide polynomials, to simplify it. And so you don't have to write this down. When you divide a polynomial f of x by a non-zero polynomial divisor d of x, you get a quotient here. So this here is essentially the whole number, the number that we had for the last one, plus the remainder. Now, one of the main goals, especially with long division, when we start dividing, we have so far, but y'all have not discovered, or we have not covered a way to solve for degrees higher than 3. Because if the degree of the polynomial is greater than 3, we don't really have a way to solve for them yet. But if I have a degree 2, a quadratic, we have several ways to solve quadratics, yes? And with dividing, what we're going to be able to do is take the degree of whatever it is and decrease it down. So when we start solving, the main goal is to get it back to a quadratic, degree 2. Because if I can get it to there, then we can solve it from there. And dividing is one way that we can simplify these here. And what we're going to do today is one of the two ways that we can divide polynomial functions. One of them is with long division. The other is what we call synthetic division. Now with long division with this here, we're going to start off the same way we did on the other one. So we'll have our little house here. The one that we have first goes first. So we have x cubed minus x squared plus 2x plus 8. If there is a term missing, we have to put it back in as 0 times x to whatever that power is. So here the biggest one we had was x to the third, x to the 3, yes? So that means if we have x to the third, we will need a term with x squared, we'll need a term with x, and we'll need a constant. So if we had x to the third but no x squared, we would add it in as plus 0x squared. We need every term taken place. And there will be a few that we look at where we don't have them. And then we put what we're dividing by out front. Now here's the first spot, it's a little bit different. When we do the division, we're wanting the first term to cancel out completely. So the first main question we have when we divide is what times x will give me x to the third? What times x will give me x to the third? X squared, because x squared times x is x to the third, yes? Because when we multiply, or what we're trying to multiply on top, is we're trying to get this first term, so here it's x to the third to cancel out. So we look at the first term we have over here. So we're looking at what times x gives me x cubed. And it's x squared. So we'll multiply x squared by x plus 1. X squared times x is x to the third. X squared times 1 is going to be plus x squared. Any questions on this so far? The next thing we'll do is put it underneath. So x cubed plus x squared. Then what are we going to do? Subtract. So the first thing we have is x to the third minus x to the third, which is 0. That's what we want. We want this first terms. We want them to cancel out. Now we look at the next part. Negative x squared minus x squared would be because we have negative 1 minus 1. Negative 1 minus 1 is negative 2. Questions on this so far? Not too bad so far. So with long division, what would we have done next? We would have brought down the next term, plus 2x. Oh, sorry. I forgot to write that. Because when we find out what we're multiplying, we do need to put it above it. Any questions on this so far? Okay. We repeat what we just did. So now we're saying, what times x gives me negative 2x squared? Negative 2x. And when we multiply this here, negative 2x times x is going to be negative 2x squared. Negative 2x times 1 is going to be negative 2x. So we're going to have negative 2x squared minus 2x. And then we're going to subtract again. Negative 2x squared minus negative 2x squared is 0. Negative 2 minus negative 2 is 0. And that's what we want. We want these to cancel. We always want that first term to cancel out. Now, 2x minus negative 2x, well, the negative and negative make a plus, giving us 4x. Questions on this here? Is this as bad as what y'all thought this was going to be? And then we drop down the 8. Again, I did it. I have to write the minus 2 up top. Because each time we find that, we need to add it in. Because I'm going to do it on this next one before we multiply. What times x will give me 4x? 4. So here we would write plus 4. Because really I should have been doing that on the first two, because when we find out what we're actually multiplying, we can put it in. So again, off to the side, we can say 4 times x plus 1. 4 times x is 4x. 4 times 1 is plus 4. Again, we bring it over here and put it underneath, which would give us 4x plus 4. And again, we're going to...
So do we always just subtract?
Yep. Well, 4x minus 4x is 8 minus 4 is 4. Now for this here, we're not going to put remainder 4. We're going to put plus whenever we have a remainder, because we'll have a fraction, and 4 is going to go on top. Because what have we been doing? We've been dividing this whole thing by x plus 1, yes? So the remainder would be what we have over what we're dividing. That's it. Questions on this here? Any questions on anything we've done so far? Let's look at the next one. So what goes inside is going to be what's first, so our 2x to the 4th plus 3x cubed plus 5x minus 1. So we can fill it in. 2x to the 4th plus 3x cubed, yes? So we have x to the 4th, x to the 3rd. Then we'd have, are we missing a term? Because we have the 4th power, we have the 3rd power. We would need what next? We have x squared, or x to the 2nd power. We still need it, but I can add it in as plus 0x squared. 0x squared is just 0. But we have that spot. Then we have plus 5x minus 1. And either side, if we have a term missing, we'll put it in as plus 0x, or 0x to that power. So now that we have 4, 3, 2, 1 constant term. We need them all.
Do you want us to do that on the yesterday's homework too?
Well, we don't need to do it with addition, subtraction. It doesn't make a big difference. We'll see here in a minute why it's helpful. Actually, we'll see it off the first one here. Any questions on how we set this up? Okay. Now again, we're doing the exact same thing we did on the first one. So we're wanting to see what times x squared gives me 2x to the 4th. Because we'll need a 2, yes? Because we have 1 here, we need to make it into a 2, so we will need a 2. So what times x squared gives us x to the 4th? Yeah. x squared. Now, there is a little bit of, I don't know if it's a cheat per se, but how many terms do we have outside of this little house? 3, yes? So here's 1, 2, 3. What variable do we have in the third spot? X squared, yes? So what are we multiplying by? They line up that way. So we know our first one is going to be x squared, and it is 2. So sometimes you can use the number of terms, move over that, especially if we have every single one listed, and it kind of gives us that there. Now what we're going to need to do is multiply 2x squared by our x squared plus 3x plus 2. I'm going to have to write it below it because I just don't have the space off to the side. 2x squared times x squared is going to be 2x to the 4th. That does match up with our first term, just like we wanted. 2x squared times 3x, 2 times 3 is going to be plus 6x cubed. And 2x squared times 2 is going to be plus 4x squared. Then we can place it underneath 2x to the 4th plus 6x cubed plus 4x squared. Then what do we do? Subtract. 2x to the 4th minus 2x to the 4th is 0. Three x cubed minus 6x cubed. 6 minus 3 is going to be negative 3. And then we have x to the 3rd. Now, we needed that 0x squared because if we weren't paying attention, there's a good chance you would have subtracted, done 5 minus 4. But they're not like terms. We don't have an x squared. So really, what do we have? 0 minus 4. Almost. It would be negative 4x squared. 0 minus 4 is going to be negative 4. Questions on that there? It would be very tempting, and I've seen it, just put down as 4, but our 0 minus 4 is going to be negative 4. And then we bring down the next term, because again, we have 3 terms for what we're dividing everything by. So in this here, we'll need 3 for it to match up. Questions on this here? Now we're essentially just going to repeat that whole process again. But this time we're saying what times x squared gives me negative 3x cubed. Negative 3x. And again, I said we started over 3 terms, yes? So we started over and got this here. What's the next spot after the x squared? X, isn't it? So x times x squared would give me x to the 3rd. Y'all kind of see how that works? X squared x, they'll be decreasing in power. If not, that's fine. Because x squared times negative 3x would give us negative 3x cubed. And we'll multiply again. Negative 3x times x squared is going to be negative 3x cubed, which does match up to our first term. Now we'll do negative 3x times 3x, which is going to be negative 9x squared. And lastly, negative 3x times 2 is negative 6x. Then we are going to subtract again. Negative 3 minus negative 3 is 0, because it's negative and negative make a positive, so negative 3 plus 3 is 0. So this is 0. Our next one, negative 4x squared minus negative 9. Well, the negative would make a plus. So negative 4 plus 9, or 9 minus 4 is 5x squared. 5x minus negative 6x. Negative would make a plus. So 5x plus 6x is plus 7x. We bring down the next term. Questions on any of this here? Well, we're going to do it again. What times x squared will give me 5x squared? What times x squared will give me 5x squared? 5, yes? And it would be positive, so we'll put plus 5. So the last one we'll have is 5 times x squared plus 3x plus 2. Well, 5 times x squared is 5x squared. 5 times 3x is going to be plus 15x, and 5 times 2 is going to be plus 10. And again, we're going to subtract. So we'll have 5x squared minus 5x squared is 0. We good? Okay. Yep. These would cancel. 11x minus 15x. 11 minus 15 is negative 4x. And negative 1 minus 10. Negative 11, yes? Okay. Do I have another term I can bring down? No. What is the degree of what I have left? What's the biggest exponent with what I have left at the bottom there? What's the biggest exponent we have? 1. Because x, yes? X is to the first power. We don't write it, but we see that it is to the first power, yes? Is that less than the degree of what we're dividing by? So we're done. That is another way we can make sure, kind of for you to be able to see, are we done? When the degree of what we have left is less than the degree of what we started with, or what we're dividing this by, then we are done. That's as far as it can go. So, any questions on this here? So, we can write it as a remainder. So what we found is the answer is 2x squared minus 3x plus 5, yes? Plus. So what we have left, negative 4x minus 11, we can put it on top. And what have we been dividing this whole thing by? X squared plus 3x plus 2, yes? And that's it. It is a lengthy process. It has a good number of steps, but each individual step that we're doing isn't overly complicated. We just take it one step at a time and work our way down. Questions on any of this here? Now, if a number does become 0, instead of leaving it out, just put 0 times that variable. Any questions on anything we've done so far? Let's look at another one. I thought that'd make it a little bit easier to read. and I'd give you all a headache looking at. But what we're going to do is the same as what we just did. So we'll put the first polynomial first. So we start off with 4x to the fourth. Yes? Our next term would be x cubed. Do we have an x cubed term? No, so we'll put plus 0x cubed. What's our x squared term? We don't have one, so we'll say plus 0x squared. Well, luckily we do have an x, so plus 5x. And that's probably the only time that you'll say that. Luckily you do have an x. Minus 4. And the other one goes out front, and we do have x squared minus 3x minus 2. Out front. Questions on setup? So the first thing we're going to see is what times x squared gives me 4x to the fourth? X squared is going to be part of it. 4x squared. Because 4x squared, 4 times 1 would give us the 4. The x squared times x squared would give us x to the fourth. So we're going to multiply 4x squared by x squared minus 3x minus 2. X squared times 4x squared times x squared is going to be 4x to the fourth, the first term. Then we'll do the next one, 4x squared times negative 3x. 4 times negative 3 is negative 12. X squared times x is x to the third. And lastly, 4x squared times negative 2 is negative 8x squared. And we can put it underneath. So 4x to the fourth minus 12x cubed minus 8x squared. And then we will subtract. Questions on this so far? So 4x to the fourth minus 4x to the fourth is 0, just like we wanted. 0x cubed minus 12x cubed. Well, here the negative and negative make a plus. This would just 12x cubed, because 0 plus 12 is just 12. Next one we have 0 minus negative 8. Negative, negative make a positive. 0 plus 8 is plus 8, and we have our x squared. Now we bring the next term down. Repeat the process. What times x squared gives us 12x cubed? And it'd be positive 12x, yes. Then we'll do the multiplication again. 12x times x squared minus 3x minus 2. 12x times x squared is going to be 12x cubed. 12x times negative 3x is going to be negative 36x squared. And 12x times negative 2 is negative 24x. And then we're going to subtract. Twelve x cubed minus 12x cubed is 0. 8x squared minus negative 36x squared. Well, again, the negative and negative make a plus. So 8 plus 36 is 44x squared. 5 minus negative 24, negative, negative make a plus, which would be plus 29x. And last but not least, we bring down the -4. So what times x squared gives us 44x squared? Well, positive 44. Yes? And we'll do it again. 44 times x squared minus 3x minus 2. 44 times x squared is just, well, 44x squared. 44 times -3x. Well, in a calculator, you could do -3 times 44, which would give you, I believe, -132x. 2, carry the 1. And 44 times -2 is -88. And we can put it underneath. So 44x squared minus 132x minus 88. And again, just like before, we're going to subtract. 44x squared minus 44x squared is 0, just like we wanted. Our next one, 29x minus -132x. Well, the negative and negative will make a positive. So it will be 161x. -4 minus -88. Well, the negative and negative would make a positive. So we have -4 plus 88, which is going to be plus 84. Now we could rewrite it out, but I have a feeling at this point you do have some space next to what we divided by on top. If you do, we could go on and just say plus. So let me 161x plus 84 over our x squared minus 3x minus 2. Or we can write it back out with that to the side. Any questions on any of this here? Any questions on anything we've done so far?
The remainder goes plus.
Yes. Now, I will go back to the previous one to point this out. So if we notice on the previous one, we do have -4x minus 11. If I pull a negative, I factor that negative out of the top. So we still have 2x squared minus 3x plus 5. So if I pull a negative out of the 4x, it's going to become positive, yes? And if I pull a negative out of the 11, we get this here, yes? So I could pull that negative out and say minus because we can move it out front, but we take it out of every term in the numerator. I will take the -4x minus 11 and with the plus in front. But if you do factor it out, you have to factor it out of every term in the numerator. Because all I did for the numerator was just say -1 times 4x plus 11, and then move that negative out front to make it subtraction. Either way works. But for the most part, we'll just have plus and then what's left over. Any questions on anything we've done so far? Do we feel comfortable with these here? Yes? This is the last one we'll look at today, because I feel like y'all are getting the hang of how these work. Inside here, we'll start off with x to the 4th. But we don't have an x to the 3rd, so we can add it in as plus 0x cubed. We do have an x squared, We don't have an x, but we do have our constant term. So we have x to the fourth plus 0x cubed plus 4x squared plus 0x minus 45. Outside we have x squared, but I don't have an x term this time. So we can say plus 0x plus 9. Yeah. I think you're good if you leave it there because I think I jumped. I jumped several. I jumped all the way to the back. You're good. You can leave it there just as you make a note that it's not the problem above. And there's a reason I'm looking at this one here is because all the ones up to this point we've had a remainder. I want to look at one where we don't. Now the first main question is what times x squared gives us x to the fourth? X squared. This time we just have x squared. So we can say x squared times x squared plus 0x plus 9. Well, x squared times x squared is x to the fourth. X squared times 0x is going to be plus 0x cubed, because it's still 0 technically, but x squared times x is x to the third. And x squared times 9 is going to be plus 9x squared. Any questions on any of this here? And then again, we're going to subtract. X to the fourth minus x to the fourth is 0. Zero x to the third minus 0x to the third. Well, it's just 0, isn't it? So we can technically cross that out if we want. It's just going to make something a little weird here in a second. Now the next thing we have is 4x squared minus 9x squared. 4 minus 9 is negative 5x squared, yes? Any questions on what we've done so far? We good with this here? So what would we do next? We bring down the 0 plus 0x, yes? Well, how many terms do I have left over right now? 2. How many am I dividing by? 3, yes? I don't have enough terms. I have to bring the next 2 down. Just like when we divide with log division, if the number that we have is not big enough, where we bring the next number down with it, instead of bringing 1, we brought 2. It's the same process. Because now we're trying to see what times x squared gives us negative 5x squared. Well, we already have the x squared, yes? All we need is the minus 5. We wouldn't have that if I had left it as 0x cubed. But what times x squared gives us 0x cubed? 0x. So it doesn't add anything. So now we're doing negative 5 times x squared plus 0x plus 9. Negative 5 times x squared is negative 5x squared. Negative 5 times 0x is plus 0x. And negative 5 times 9 is negative 45. So we have negative 5x squared plus 0x minus 45. And again, we're going to subtract, yes? Give y'all a second to write because I think I'm getting ahead of y'all. So if we subtract negative 5 minus negative 5x, we can say it's really negative 5 plus 5 is 0, just like we wanted, yes? 0 minus 0 is, well, still. And lastly, negative 45 minus negative 45 is 0, because we could say that's a plus. Negative 45 plus 45 is 0, so the whole thing became 0. So what's our remainder? X squared minus 5 is the answer. So if we don't have a remainder, it's just what was on top. That's our answer. Questions on any of this here? Not too bad? What we're going to do tomorrow is even easier. It's even simpler than this. And twice as fast. So that is the end of that note sheet. Page 187. Problems 5 through 100. No, 5 through 10. 5 through 10. 5 through 10. No, I'm not making you guys do a ton of these because, again, they're so long. And these here are not too bad. I'm not going to make you do a bunch of them because I feel like doing these 6 problems is going to be more than enough for y'all to get the concept down and understand what you're doing.